I hope you made it to this screencast. You were probably ready to throw rotten food at the screen after watching the last screencast because putting that uh, 3 by 4 system into reduced row echelon form is really, really tough. But it's super easy on the calculator. And that's what I'm going to teach you to do today. So let's get started. Make sure you have your calculator handy. Pause the screencast and go with it and get it if you don't. Okay, so we're going to do 3 examples today and then we'll be done. We're doing them all on our calculator and I think you're going to love this. Okay, so we have our system 4x minus y minus 3z equals 1, 8x plus y minus z equals 5, and 2x plus y plus 2z equals 5. And we're going to write that augmented system. Now we're going to write that augmented matrix. I shouldn't say system, augmented matrix. We're going to put that in our calculator. So see this word matrix on your calculator? We're going to access that. Press second and the inverse button. Now you might have things here that I don't, which is fine. Don't even worry about it. We're going to put a new matrix in matrix A. If you have one there, don't worry about it. You'll end up typing over it. So we'll toggle over and press edit. And our system is 3 rows by 4 columns. So it's a 3, press enter, 4, press enter system. Now that pulls up a matrix, that's 3 by 4. And we're going to plug in these coefficients. Be very, very careful. Make sure you plug these in correctly. So I'm going to press 4, enter. -1, make sure you're using this negative button and not the minus, and then another -3, and then a +1. Press enter after every single entry. Then 8, 1, -1, and 5, and 2, and 1, and 2, and 5. I always stop and look at it and check each column to make sure that they match. 482, -111, -3, -12, 155. Making sure I didn't make any mistakes in here. Okay, so that's done. Okay, great. So you have your matrix in there. So what you have to do now is press second and quit to get back to the main screen. And what we're going to do is we are going to have the calculator put this into reduced row echelon form. So you have to press second matrix again, but this time instead of editing it, we're going to toggle over to math. And I always use the up key. You can use the up or the down, but look for the expression RREF. That stands for reduced row echelon form. So RREF, not REF, but RREF. Press enter. And it's asking which matrix. So we remember put our matrix, we edited it and put it into matrix A. So we'll press second in matrix and enter for A, close the parenthesis, and press enter, and it gives us our answers. Now, notice these answers have decimals in them. If you want to change them to fractions, just like you did before, press the math and the enter, and enter again, and that puts them into fraction form. I have those written here. So the solution, okay, so that's just the tool. That gets us to here. But then that tells us x equals 3 halves, y equals -4, and z equals 3. And that's the solution. Awesome. Okay, moving on. Let's look at another example. So let's do that same thing and put that information in our calculator. So remember, it's second matrix, and we're going to edit this matrix. It is still a 3 by 4, but we have to change the coefficients. So I'm going to pause the screencast and do that. You do the same. So make sure that you have all of these coefficients correct. 113, 1 -11, 1 -11, 9, negative 15, and 2. So I did a quick check. So once you know you have all of those, second and quit. I'll clear this so you can just see this. And then we're going to, oh, by the way, I had this on the screen. But the next thing we're going to do is press second matrix again. And this time we're going to do that reduced row echelon form. So we toggle over to the math menu, use the down arrow, looking for reduced row echelon form, RREF. And we're going to use matrix A in there. So you get this answer. Now this looks a little weird. Okay. See this? This is not in reduced row echelon form, is it? So this row right here is very, very concerning because what that says is this says m equals 0. This says n plus t equals 0. These are fine. But this says 0 equals 1. And that's not true. So this system has no solution. The big clue is this row that has zeros and then a 1. Look for that. If you see that bottom row looks like that, there are no solutions. Okay, one last example. Let me clear this for you. And let's do the next one. Okay, so in the next system, we're going to put that in our calculator, second matrix, toggle over to edit. Notice the old one's in there. We're just typing over it. So it's a 3 by 4. And I'll pause and put my values in again. Once again, let me mention that you want to check to make sure that you have all of the correct values. If you're going to screw this up, it's going to be because you didn't type these in correctly. So always take that extra 10 seconds to make sure you've plugged everything in correctly. Okay, so once you have those all in there, now what you're going to do is go back and do that second matrix and RREF. And we're doing that to matrix A again. And press enter. And this one looks a little funny too. So notice we have this row of zeros. When you get a row of zeros, that means there are an infinite number of solutions. Now, more than just saying there's an infinite number, we have to talk about what those solutions are. So we're going to write down the equations that we get from this system right here. So the equations that are associated with this system is the P minus R is equal to negative 2 and Q plus 2R equals 3. Make sure you understand where these equations come from. They're associated with this system. Now what we're going to do is solve each of those for R, or you could think of it the variable that is farthest to the right in the alphabet. So the farthest to the right, farthest in the alphabet is R. So we're going to solve those for R. In terms of R is what I should say. Okay, so I said solve for R, but I should have said solve in terms of R. So we're going to have P in terms of R and Q in terms of R. So when I do that, I'm just simply adding R to the other side. So P is equal to R minus 2 and subtracting 2R from both sides. And so Q is equal to negative 2R plus 3. And so the solution set is P, which is R minus 2, Q, which is negative 2R plus 3, and R, which is the variable R. So that's like a formula that generates all the solutions. If you remember, we did that a couple screencasts back. Okay, I hope that helps. Email me with all of your questions.